And here we can write x2 also. Because we have x2 also. So let us write here.
Yeah.
Now let us put the value of x1 here. Okay. Then simplify. So 3 and in bracket we have minus 2 over 3 plus square root of 15 into x2 is equal to, are you getting me?
Yes.
And is equal to, we have this. Is equal to minus and minus 3 plus square root of 15 into x2. One second. Something is missing or something. Because we need to find only relation. Because we can't find a certain value, okay? In eigenvectors, we can't find a certain value. So we can conclude from here. I'm telling you, we can conclude from here. So if we have, see, as I told you that day also, I'm telling you again, like in
Yes, ma'am.
eigenvectors, we will find relation between these x1, x2, or if we have by 3, then we will have x1, x2, x3. We will have a relation. Okay. So we will consider value of that variables in which we explain another variable. Okay. In terms of we explain another variable. So let us take, because we can explain this x1 in terms of x2. So let us consider x2 as a 1. So let x2 is equal to 1. Then x1 will be minus 2 over 3 plus square root of 15. And I'm checking one thing again. We have taken matrix. I'm just checking it again. 7231. Okay. Because maybe any mistake, because in both equation we must have same coefficients. That is why. So a minus lambda into I is equal to 0. We are taking determinant of a minus lambda into y. So a 7231 minus lambda into I. 7231, okay. So 7 minus lambda, 2 minus 0, 3 minus 0, 1 minus lambda, okay. Then 7 minus lambda into 1 in 1 minus lambda and minus 3 into 2. So 7 minus 7 lambda minus 1 lambda and plus lambda square. Okay. Because I have taken a random question, okay? Next question I'll do from your question paper, okay?
Okay, ma'am.
Yes. So lambda square minus lambda plus 1. Yes, 7 minus is plus 6. Okay. Take it 0. And for next, minus b plus minus b square minus 4ac. So a is 1 and c also 1. So, and b is minus 8. So minus 8 square is 64 and minus 4 is 60. And minus minus plus 8. And we will have 6 square root of 60. Then we can write this 2 root 15. Okay. And we will have lambda is equal to 4 minus square root of 15 and 4 plus square root of 15. Okay. So till here you got how to find eigenvalues?
Yes, ma'am, I got.
Okay. So I'll tell you because this will be like we can find eigenvector also, but you are doing for first time, so you maybe got confused because we have these four plus like values in a square root because they'll give you little simple as you have in your paper. Okay. So let us do
Yes.
eigenvalues from there. Is that okay with you?
Okay, ma'am.
Because I have taken because we can do from here also, but I want to tell you like in easy way. I have taken a random question.
Okay, ma'am.
So I'm telling you your question. Because they have given to you very easy question here. Question number 7. See, question number
Yes, ma'am.
7. You have a 2 by 2 and yes, having easy way. So let us do 7th question, which is related to the current topic. We have A is equal to having element 1, 2, 3, 2. So to find eigenvalues, we need this A minus lambda into I. So let us find it. 1, 2, 3, 2 minus lambda into I is identity matrix.
Ma'am, where are you writing? I can't see.
You can't see? Okay, I'm sharing you again, okay?
Okay, ma'am.
Just a second. I have taken new whiteboard
Okay, ma'am.
or want to see the previous one also. What do you say?
Yes, ma'am.
So question number 7.
Yes, ma'am.
Given that, can you see the whiteboard?
Yes, ma'am. Now I can see.
Given that A is equal to 1, 2, 3, 2. To find eigenvalues and eigenvectors, put determinant of A minus lambda into I is equal to 0. But to find determinant, we need to find first matrix A minus lambda into I. So let us find A minus lambda into I is equal to A having element 1, 2, 3, 2 and minus lambda into I. 1, 2, 3, 2. Inside we have 1, sorry, lambda, 0, 0, lambda. 1 minus lambda, 2, 3, 2 minus lambda. Now let us put this determinant as 0 also. 1 minus lambda into 2 minus lambda. Are you getting me?
Yes, ma'am, I get it.
Now let us put this determinant is equal to 0. Okay, first let us simplify more. So we have here 2 minus lambda minus 2 lambda plus lambda square minus 6. And we can write in order after simplifying. So lambda square minus 3 lambda and minus 4 we have. So let us put this is equal to 0. So lambda square, put determinant of a minus lambda into I is equal to 0. So lambda square minus 3 lambda minus 4 is equal to 0, which is characteristic equation.
Yes, ma'am.
Which is characteristic equation.
Ma'am.
Now solve it by using quadratic formula. So here, let us compare this equation with standard form of quadratic equation. I'm telling
Yes,
you
ma'am.
again quadratic formula here. This standard equation, or we can say standard quadratic equation, is this a x square plus bx plus c is equal to 0. Then value of x we can find by taking minus b plus minus square root of b square minus 4ac upon 2a. This is quadratic formula and we will use here for this equation, characteristic equation. Okay, this is.
Yep.
So here a is equal to 1, b is equal to minus 3, and c is equal to minus 4. So let us put in quadratic formula. So lambda is equal to minus b. Value of b is minus 3 plus minus square root of b square minus 4 into a into c upon 2 into a is equal to 3 plus minus 9 and plus 16 upon 2 is equal to 3 plus minus square root of 25. So square root of 25 is 5
5.
upon 2. So let us find one by one. One will take negative value and another one we take positive. 3 minus 5 divided by 2 and 3 plus 5 divided by 2. So 3 minus 5 we will get minus 2. divided by 2. And lambda is equal to 8 by 2. So lambda is equal to -1 and lambda is equal to 4. Okay. So
Yes,
eigenvalues are
ma'am.
-1 and 4. You got?
Yes, ma'am, I got.
So eigenvalues are -1 and 4. Now we will find eigenvector. See, because we need this equation again, this matrix again, that is why let us mention this one. Because to find eigenvectors, we not determinant, we need matrix. This take as 1. Okay,
Yes, ma'am.
because we need it again. So there's no need to find again and again. Take it as 1. So we can give reference of that. So let us write here from 1 like this. From 1. We have, or can take from equation 1 also, you can mention here. A minus lambda into I is equal to, we have 1 minus lambda, 2, let me check it again. 1 minus lambda, 2, 3, 2 minus lambda, okay. 3, 2 minus lambda, we have this. To find eigenvectors, put A minus lambda into I into X is equal to 0 matrix. To find eigenvector for, let us take any eigenvalue, okay? Either you can take lambda is equal to 1 or you can take 4. So I'm telling you for lambda is equal to -1 and you will find yourself for lambda is equal to 4. Is that okay with you?
Yes, ma'am.
So from here for lambda is equal to -1. Let us find this A minus lambda into I is equal to. In a state of lambda, let us put -1. So 1 minus 1. Why? Because 1 minus lambda and lambda is -1. That is why. And 3 and 2 minus lambda. So from here, A minus lambda will be is equal to, you will have 3, 2, 3, 3. Sorry, 3, not 3. Here we will have 2. Just a second. 2, because 1 minus -1, we have 2. And here we have 3, 3. So this is matrix A minus lambda into I. You got from, sorry, from 1 and 4, lambda is equal to -1. You got?
Yes, ma'am, I got. I
So
just
let us
found.
put here value. So here you have in first row, you have both values 2, 2, and here you have 3, 3. And because this is 2 by 2 matrix, so let us take 2 components in this vector. And right side, you can take 2 component in 0 matrix. So let us multiply first row with with this column. So you will have 2x1 plus 2x2. And below this, 3x1 plus 3x2 is equal to having two components 0, 0. So let us compare on both sides. So 2x1 plus 2x2 is equal to 0. And 3x1 plus 3x2 is equal to 0. So from here, let us take 2 as a common. 2x1 plus x2 is equal to 0. You can solve any one of them, okay? Not both, only any one of them. So we will have x1 plus x2 is equal to 0. Then x1 is equal to minus x2. Okay, we got this relation. If we have like matrix of 3 by 3, then that condition we need to solve two equations. Okay, to find
Okay,
relation
ma'am.
between three variables. So we got this relation. So obviously x1 is in terms of x2. So let us consider x1. So
Ma'am,
yes,
ma'am, why you don't write 3 common in the second?
which one?
Ma'am, you didn't write 3 in the this column. मैम जैसे आपने ऊपर 2 लिखा है 2 कॉमन लेके, ऐसा आपने 3 कॉमन लेके क्यों नहीं लिखा
नो
मैम
नो, ये मैंने
इसमें?
ये लिया ही नहीं है, मैंने ये वाली इक्वेशन नहीं ली, मैंने सिर्फ यही ली है. ओके,
ओके मैम, ओके
yes,
मैम,
you can do this as also 3x1, take common as common, because I'm saying that just you can solve any one equation, okay, to find relation between two variables. If you need to find relation between three variables, then you need to solve two equations. Okay,
ओके मैम,
in that condition which you have matrix of 3 by 3, in that case you need to solve two equations because you need to find relation between three variables. Here you have only two variables, so you can find relation easily by solving one. Okay, so here
yes
you
मैम,
will also find the same relation because we have the same variable, that is why. Okay,
मैम सेम वेरिएबल.
yes. So now let us take, because we found x1 in terms of x2, so let us consider x2. How? Let us take x2 is equal to, let x2 is equal to 1. Then x1 will be minus 1. Okay. So
Yes
by
मैम,
taking them as a column matrix like this, x is equal to having x1, x2. So let us put the values. Having minus 1 and 1, because x1 is minus 1 and x2 is 1. So is eigenvector for lambda is equal to minus 1. Okay, we found this for lambda is equal to minus 1. You got it?
yes मैम, आई गॉट इट.
So now you need to do for lambda is equal to 4. Okay, I have done for you this, and now you need to do this. Okay, similarly, mention me your mail address so that I can send you this whiteboard so that you can practice.
ओके मैम, आई
Okay,
हैव ऑलरेडी सेंड.
so you have written all things.
नो मैम, आई डिडंट हैव रिटन. यू कैन प्लीज शेयर मी.
Oh, sure, sure. So mention me your mail address. You have mentioned already?
Yes मैम, आई ऑलरेडी मेंशन.
All right. All right. I'll share you, okay?
ओके मैम.
All right. So you got each and everything today or have any
Yes,
doubt? You got?
yes मैम, गॉट इट.
All right.
यस मैम.